Interpreting the mean value theorem. So we're going to talk about how the mean value theorem actually applies in a real life situation and what the different portions of the mean value theorem says. Previously, we've solved for values such that the mean value theorem holds true by finding the average rate of change, which is the average slope, using the difference quotient, or the change in the y divided by the change in the x, and comparing that or setting it equal to the derivative at some point. Now recall that the f of b minus f of a divided by b minus a is the average rate, which is found by using the difference quotient. The derivative, f prime of c, or f prime at any number, is the instantaneous rate of change. This means that we're setting the average rate equal to the instantaneous. So the mean value theorem says that at some interior point on the interval, a to b, the instantaneous change must equal that of the average rate. That means that if you travel at 60 miles an hour on average, then at some point, because you were traveling slower than 60 miles an hour, you are also traveling faster than 60 miles an hour at some point. This means that you obviously had to cross 60 miles an hour at some point to be going faster. So we're going to use that to do an example. So example 4 says a car accelerates from 0 and it takes 8 seconds to go 352 feet. This means that it's accelerating at maybe not a constant rate, but that it takes 8 seconds to go 352 feet. So right here is a graph, and I recommend you go ahead and pause the video right now, take a second to draw this in. And this shows the blue graph is the position of the graph, or position of the car rather, at certain times, 5 seconds, 6 seconds. And we're going to use that to determine the average velocity. Because since the derivative of position is velocity, then the tangent line or the slope of the tangent line is going to represent the velocity at a point. So as you can see right here, let's focus in right here. This is, we're starting at 0, 0. It's been 0 seconds. We've moved 0 feet, or 0. It's been 0 seconds. We've moved 0 feet. And after 5 seconds, we move this much. And after 8 seconds, we move this much. So this is saying that we start out kind of slow, but then maybe we step on the gas and we accelerate faster. Or we start gaining more speed. So our position is going to change faster. So the mean value theorem says that if we find the average speed, then the car had to move at that speed at one point. So interpreting the mean value theorem is going to say, so its average velocity is 352 feet. That's how far it's traveled, divided by 8 seconds, how long it took it to travel, which reduces down to 44 feet per second. Now, 44 feet per second doesn't mean much to me, so I'm going to go ahead and I'm going to convert it into miles per hour. So we need a couple conversions, and this should just be off the top of your head. You should know that there are 5,280 feet in 1 mile, and that there are 3,600 seconds in 1 hour. And these are things that if you don't know, you can Google, but you should know. All right, it's going to be circled. So here we have 44 feet per 1 second, and we need to get rid of the seconds, so we're going to multiply by 3,600 seconds in 1 hour. Notice that I'm making the second term in the numerator, and this because it's in the denominator, so they'll cancel. So my seconds units will cancel off. And then I'm going to multiply that by 1 mile is equal to 5,280 feet. And this way my feet are going to cancel off. And so you get that this is equal to 44 times 3,600 miles divided by 5,280 hours. And this works out to 30 miles per hour. So in the first 8 seconds, they've traveled 30 miles per hour. So the question is, how in the world does this apply to the mean value theorem? That's the big question. Well, the mean value theorem tells us that by the mean value theorem, we know that at some point of time in the 8-second interval, the car must, and must is huge, it has to, there's no if, ands, maybe, be traveling at 30 miles an hour. So again, what this means is that at some point between the first 8 seconds, the velocity right here is exactly 30 miles per hour. And that's all the mean value theorem says, is that the average rate of change is equal to the instantaneous rate of change at some point on that interval. So what I want you to do now is I want you to read this over and try it and try to answer the question. It says a trucker handed in a ticket at a toll booth showing that in 2 hours he covered 160 miles. So in 2 hours he went 160 miles. So the speed limit was 65 miles per hour on that road that he was driving on. So at the very end of it, he was given a ticket for speeding. But they didn't track his speed. They didn't wave him down with a gun. They don't know his instantaneous rate of change at any moment in time. So why was he given a ticket? So using the mean value theorem, try to figure out how they knew. So take a minute now, pause the video, and try to figure it out. All right, welcome back. We're going to figure out how in the world this trucker got a ticket. Because if I was him, I'd be pissed because I didn't get pulled over by a cop. So this is what happens in the real world. This is how calculus makes money. So the trucker's average speed is what? The trucker's average speed is 160 miles divided by 2 hours, which is 80 miles per hour. So that's his average rate. So you're telling me that if he were to cover 160 miles in 2 hours, if he was going the same speed the entire time, which is not what happened, he would already be going 80 miles an hour. But he probably was going a little slower, which means he was also going faster than this. So right there, this is the answer. You can just use the average, but using the mean value theorem, by the mean value theorem, we know that the average rate of change is equal to the instantaneous rate of change at a particular time value or an x value. So because of this, so at some point he must have been going 80 miles per hour. And that's it. That's how you interpret the mean value theorem.